Okay. So I'm starting over again just because I believe there were audio problems. Sorry if I'm repeating myself. My name is Cynthia Cradgel, and I'm with Access New Jersey, and I'm here today with my colleague Karthik Ranjajaran. We work in the automation division for Access New Jersey. Access is part of the PowerFlow Technologies Group. We're headquartered on Long Island. It's a privately held company with over 100 million in sales per year and 300 employees. Today we're going to speak about collaborative robots, and Karthik's going to show you how the program works. But before we get into the actual demo, I wanted to say a few words about collaborative robots. Collaborative robots are a new tool that's come out in recent years. They're quite different than industrial robots. Traditionally, industrial robots require fencing and separation from humans. I still have the message that there's still no audio feed. Oh, now I got the audio is good. All right, should I start over again? Okay, so I think, should I start at the beginning? Okay. All right, so I was mentioning about collaborative robots, how they differ from industrial robots. Industrial robots are caged and separated from humans. They're also fixed automation. That is, once they're set up, they often don't get redeployed to new tasks. Unlike the cobot, it's designed to work safely side by side with humans, and it's easy to redeploy. One of the reasons the cobot is easy to redeploy, as you'll see shortly when you look at Karthik's screen, what he'll show, is that we talk about this often, and people will say it's easy to program the cobot. Well, the cobot is, sorry, I'm getting all these text messages on the screen. The cobot is easy to redeploy because inside the program, you have lots of wizards and way to change things. So for example, if you're picking up a tray with 6 pieces of a part and putting it into a box, and now you wish to switch it to 8, it's a fairly recent and easy adjustment to go in and change the number of parts that you're picking and placing. You'll see that briefly when you have Karthik live. Overview for universal robots, you'll know that the names of the robots are by numbers. So there's the UR3, UR5, 10, and 16. These all relate to the payload, but each robot also has a specific reach. In addition to the robots, there's a control box and a teach pendant. And what's unique about the universal robots is that in the beginning, when they established the product line, they decided to have an open architecture. So there's a whole ecosystem of grippers, end-of-arm tools, vision systems, add-on software packages, and safety skins, and all kinds of other products that neatly interface right into the universal robot teach pendant. So when you're doing an application, it's quite easy to add on these products from the universal robots ecosystem. They're safe to use near humans, and they're easy to redeploy. They run off of wall power, like 110, so they can be put in any setting. We have lots of videos that we can share with you if you're interested. In fact, there's so many different applications to talk about. If you are on this call and you'd like to discuss a particular application during the question and answer session, please indicate what applications you're interested in. There's videos of robots on mobile carts. They're doing assembly. They're doing pick and place. They're doing gluing, welding, all kinds of applications. But for now, I'm going to turn you over to Karthik, and he's going to take you through the robot itself, and then we'll reconvene again afterwards to go into discussions related to your specific questions.
I hope you are able to hear me. Let's redo the same thing again. The interface has features like where you can connect the way you interact with your computers, the applications on your desktop computers. So you have like multiple tabs on top where you can like create programs, and you have installation file where you can define the tool center point. Tool center point defines the tool where the object is going to be picked from, and you can also define the payload. Payload is an important aspect. If in this case, like the robot has the capability to lift around 3 kilograms of payload, that excludes the tool what you're connecting to. So the tool, if in case, for example, is like 1.5 kilograms, uh, you can only pick an object which is like 1.5 kilograms in that 3 kilograms of payload. The same goes for 5 kilograms and 10 kilograms. So the robot's capability is excluding the tool. And you can also define the center of gravity. Center of gravity is another important aspect to like make sure the joints are not stressed out. So if there is like a part which are heavy on one side of the robot where it is picking, you need to define the center of gravity to that place so that the robot adjusts itself in its joint angles. And the next comes in the move tab, where you can define or create motions for the robot. There are multiple ways you can jog or control the robot's position. One is a free drive. The teach pendant allows you to have like a button. When you press it, the robot releases the brake but holds that position for you. So you can jog the robot where you want to go, and you can define in 3D space where you want to like position, and you can control all the joints along. And the other way is to use the move tab, where you can control the robot based on its position. You can define whether it can go up, down, right, left, and also you can control the TCP orientation. As you can see here. And another important aspect here is the universal robot comes with force torque sensor built into it. The E series has the force torque sensor built into it. The older version comes with an external force torque sensor. So with these, you can define based on the force torque sensor, you can define the positions as well. The your caps allows you to like control the active drive, and without touching the teach pendant or the free drive, you can apply force and control the robot in its 3D space. And input-output tab allows you to define or connect to multiple peripheral devices like encoders, motors, or if there are like machines where you need to you can connect multiple devices through it, and you can also control through that. And just like your applications on your desktop computers, you can create like new programs and save those programs, and you can open and close like when you want it based on your application needs. And another important aspect is the UR Plus applications. UR Plus products are authorized by UR to allow and easily to connect and communicate with the universal robots. So they provide UR caps which are easy to like control or actuate the grippers. So in this case, we have like a robotic two-finger gripper where we can show the gripper being open and closed as easy as tapping the button. So now let's move on to creating a program, and this is your program section. On your left is the program tree where you connect different nodes and define the nodes variables or parameters on the right side of the screen. Different nodes involves like it has been sectioned into like 4 parts. One is the basic, which has like the waypoints and what kind of moves you want to define, like whether you want to wait or set some devices which you are connecting to. And advanced tab is like a advanced level of scripting which allows you to create like folders and scripts and events and threading. You can create like multiple programs to run parallel. And templates allows you to like define a predefined task. For example, like palletizing, and you need to like stack multiple objects one top of each other. You have like a GUI for that, which allows you to like connect multiple devices to it, multiple nodes to it, and then you just have to define the waypoints, and the program does everything for you in the background. And UR caps, as I told you, is a very important and another great feature of Universal Robot. So these your caps are like a predefined functions or programs which allows you to create as a node, and it doesn't allow you to like need any sort of programming to be done. It actuates or controls the gripper's force, position, and force torque sensor features. Let's create a simple program of pick and place. On the left side, you can see there is move. We'll like look into what kind of motions we have available. Let's just like look into how the waypoints are created. So let's create a object to be picked from this side, and it places onto the other side. So I created a move. Let's set this as a waypoint, and by default it creates a waypoint for you. And once you click set waypoint, it allows the move tab function. You can either control through free drive, or you can use the move tab. So let's create a default home position here. Let's call it as waypoint 2 here, and so what we want to do is we need to pick this object right here. So let's actuate the gripper to have it open. And what I will do is like, let's start from the object where it has to be picked. Let's call this let's create a new waypoint. Just before we go further onto this, I want to give you an detailed explanation of different move commands. So there are three move commands for you: move J, move L, and move P. So move L is linear move, meaning it can move in X, Y, and Z directions. And move J is in a random 3D space, it has to move from a different levels. That's when you can define move J. So it will find a shortest path between the 2 points. Move P is more of a process move, where you have to like apply in very specific applications like glowing or painting, or if it needs to be like in a very specific directions like welding process where it has to go in a curved surfaces. So let's define here the robot has to pick the object in a linear position. So let's create a move L here. And let's set this as a waypoint 1 right here. And from this waypoint, let's set the waypoint 2 to go straight up. Okay? And now in this waypoint, let's set the home position closer to here. So now that it comes over here, and when you click the waypoint 2 and move to that position, that's where it goes to pick the part. And this is the approach point. And from here you can move to the pick part where you can like pick the object. So instead of like reading waypoint 1, 2, 3, you can rename those waypoints. It allows you to like create meaningful names like approach. And you can rename waypoint 1 as pick. So in this way, when you like look back into your program, you can understand like what it means. So basically, what the program is doing is connecting multiple nodes with different motions, and in case like the grippers, it's actuating, so it connects all these nodes into one program. So before approach, let's say we activate the gripper in that position. So what we would do is, just before approaching, let's make sure that the gripper is open to pick the part, so that like it can pick the part and then close when it's picking the parts. So here, let's say that the gripper is being closed, and that's when the object is logged in. And then we can create another waypoint for it to pick all the way up. And here, what we can do is, we can link different waypoints. So I'll show you how to link different waypoints. Right here, there is like a chain link. We can make the robot to go to the home position, so that we don't have to define that new waypoint again. So it directly links to waypoint 3, which is the home position right now. So it says that waypoint is linked to waypoint 3, and now when we move to waypoint 3, that's when it goes to the home position. And now let's create a new drop-off point. Let's create a move J here because that's a new waypoint over. And now that the robot is in the home position, let's create a new waypoint where it has to drop it off. So let's make the robot move to this waypoint right here. And from here, let's create a new move, a linear move, so that like it goes all the way straight down to in the Z direction. And once it reaches this point, we need to activate the gripper to open. And click save. And it goes over to waypoint 3 as the home position. So let's link to the home position. And now when we run the robot and place a part here, and if we click run, so your program is going to be executed one after the other in the sequential order. There you go. So this is a simple program of pick and place which can be done in few minutes. If you have like a different applications where it has to pick from a random points to a random places, then you can define a palette, or you need like an external vision system to detect where the parts are. And based on the coordinates from the camera, you can like pick it up and feed it into a machine or place it into a conveyor based on your application needs. And the reason why they are called cobots is when the programs are running, and in case if it detects that it hit something or it bumped into someone, like if it's working alongside a human. This is another important aspect. When the robot's running and it detects something, it goes into a protective stop saying that it hit something, check the payload, the joint has detected that it bumped into something. Until you click enable robot, the robot's not going to do anything. So once you click enable, the program wherever it was running, it stops right there. The person can look into what it bumped into and clear the path for the robot and continue playing, and it works from the same point. So this is another important aspect, and so this is another important aspect of the robot where you can you have like a if it bumps into people, that's when it knows. You can also do this by creating safety planes. For example, if the robot crosses beyond certain point, you know, like if someone's working alongside, you can reduce the speed for the robot when it comes over to the other side, but when it runs on the other side, it can like slow down. So let's see what the safety planes are. So for the robot, when you define a safety plane, you can have it in a reduced mode or in a triggered mode. Like the robot slows down when it comes over to the other side. The robot knows, okay, so this is the safety plane and it needs to avoid or it needs to go slower. So the UR allows you to create those features, and by default I've created a plane here. As you can see, this is a safety plane on the side of the robot. And this is the plane right here. Right now it's not activated, and once I click the password and say unlock, it shuts down the robot. It allows you to modify these planes. And right now, as you see here, in the restrictions it says disabled. The plane what I have been created, it says restricted. Right now, if I change it to trigger reduced mode and say that there is a displacement of 100 millimeters which I created, based on your applications, you can define the safety plane on X, Y, or Z, and in whatever 3D space you need to, based on like if it's working alongside a human or a machine. For example, if the robot is going beyond its length to the machine, as it goes closer to the machine, you can have it in a reduced mode. And once I hit apply, it would restart the safety for a confirmation. And once you click confirm safety configuration and you power it on, it boots and goes to idle and releases the brake. And when you run the program, as you can see here now, let's try again. As you can see here, as the robot continues from the home position and it reaches the safety plane, it would slow down, and as it reaches away, it would go faster. If you had to like see, no, wait here, maybe what I can do is, you can move all along the safety plane. As you can see, it's crossing the safety plane right here. As you can see here, it slows down on the other side, and on this side, as it keeps coming over and reaches the safety plane, it knows, okay, so I can go faster on this side. Okay, that's another important aspect of safety planes. And another important aspect here is to like, that's when I applied more force, like it knows that it detected much force, the higher force and speed, and it's in a violation. And another important aspect here is the payload. There are active payload and then installation payload. Installation payload is, or could be the gripper or the end of arm tooling attached to the robot. It knows this is the payload before starting the robot, or when it starts when it boots up, this is the payload it knows it. And the active payload is something which the robot is doing some process and it's picking a part and placing it. So that's a dynamic change in the payload. For example, if the universal UR3 is having a 1 kilogram gripper connected to it, and it picks another 1 kilogram of part or a payload. So there is like a 2 kilograms of payload put onto the robot, but it knows that there is only 1 kilogram of gripper or the end of arm tooling attached to it. So the active payload or the dynamic change in the payload is to be set up while you're programming it. So the robot knows how much force and how much torque and what kind of the speed, acceleration and momentum has to be generated for the robot to like do the processing and keep the joints safer. Okay. And another feature here is the local mode, where you can see that the local mode allows you to control the robot through the teach pendant, and there is option for you to go to a remote control mode where you can like disable the teach pendant and have a computer connected to it, and you can write your own Python script and program through the robot. And you can look at this in our upcoming blog where you can see how to control the robot through a Python code, write a script, and how do you send the script functions to the robot. And connecting that is through the network settings. You can set up the IP addresses and then like connect the robot through this, and you can send the scripts and Python scripts to the robot. Right? Is there anything, Cynthia, you want to add?
I would like to, I think you've covered a lot of the basics, and I think what would be interesting to talk about maybe is some applications. So should we talk about pick and place and other applications, or what did you plan on doing next, Karthik?
We could look at the palletizing, or yeah, you can do palletizing. It depends on the applications. Based on the application needs, that it can be done with variety of different applications based on like pick and place, palletizing, machine tending, gluing, screw driving. Let's look at the template file. So there is a pallet program where you can create palletizing or depalletizing, meaning like you're stacking the parts one after the other. In case like packing boxes, you can define the width, the size, and height is all fixed. So you know like where the parts are to be positioned in what order. Uh, Once you pull out the palletizing node, so it generates a pattern and layers and what has to be done at each layer. So what we can do is like in palletizing, you can define the object height. In this case, the object height is like 40 millimeters. You can define the 40 millimeters right here. And what kind of a pattern are we looking for? So the GUI allows you to like define the predefined palette designs. So you can do it in line, the grid, or if it's like an irregular shapes, you can define it. And then comes the multiple layers. If the layers has to be stacked in, you can add a separator if there are like a sheet or cardboard sheets being placed between the layers. So let's look at the line, and let's say like these two has to be picked. It allows like how many items to be placed. Right now, let's say like we can also add 3 if you want. Let's say 3 here. And the start item allows you to set where the start item of the objects is. So what we can do is, we can say that this is the start item. Let's align on the z-axis. And what's the end item? Let's move it to this side. And here is where you can add multiple layers. If you keep adding multiple layers, it allows you to add like several layers in the packing box with the separators if you have. Right now we have just one, so let's keep it with one. So layer 1, we have to choose a line pattern. Since we created a line pattern, let's select that. And what it needs to be done at each object or items. So this gives you a wizard where you can walk through the wizard and allows you to like set up the whole thing for which you don't have to program. It's just setting up the whole wizard and it has like the complete GUI for that. So it says move to the reference point and click next. And this is where it says the teach approach. Let's set the approach point as this here. Move to the reference point, or let's activate the clicker. So it has to be clicked here. And let's move to the reference point back again. And it needs to have an exit point. So let's say it's clear from the surface. Like if there are like objects nearby, you have to make sure it exits in the right way. As the layer goes down in the stacking, the lowest layer you should make sure that it comes out of the box completely. And finish. So once you click finish and complete the wizard, it completely fills you out all the nodes and what has been done. So what it is doing right now is it creates an approach point with a move J because it's from 2 different points and it has to go to a shortest path. And then the tool action point is where the gripper is. And then it creates a folder called tool action, meaning what the tool has to do when it approaches that particular item. So let's say at this point, we have the your caps feature where we can bring up the gripper and let's say it has to close at that. And then it exits out. So let's test it out here. So what we have to see right now is it would go to the start point. Another important thing is to open the gripper before it runs. So let's put the gripper open here. Okay. So what it should do is we have like 3 items to be picked. So the robot would pick the part. Okay, So what in the tool action, once it picks, so what are we doing? So we had to include another move function, and let's say it has to pick the part and place it on a conveyor, right? Let's jog the robot over to the side. Oops, too fast. So let's set the waypoint. Let's say that it has to place over here, set this waypoint, okay? And then from here, let's create a move L and goes all the way down. And let's say that the gripper has to open at this point. Okay, so it opens and create another waypoint. Let's go into waypoint 1. Goes back up, clears the path, and then let's go. So what this would do is, the tool action is a process where you need to define what the robot has to do once it reaches and picks the part. So in this case, the tool picks the part, and if it has to feed into a machine, that's where it would pick the part and load it into the machine one after the other in a sequential order. So here it goes, and let's add another move here for it to exit. So you can see that if this is on a conveyor, it would just pick the part, go faster. since we have the safety plane connected here, it goes slower on the other side and faster on this side. So this is a simple palette program where it is clicking in a line, and then it creates its own tool action point, allows the part to be like fed into a machine or in a conveyor or where it needs to be based on the application, and then it exits out from that. So if you have any questions, you can put it up over on the chats.
We do have a few questions.
Okay.
One of the questions is, what type of power does the universal robot need?
That's a good question. Most of the traditional industrial robots need like a high power and like industrial purposes. So this runs off through the power socket. Right now it's just connected to the 110 volts power socket, and it powers on the controller, and that feeds a 50 volt supply to the robot, and that's it. You can just plug and play onto a usual power socket where you connect your laptops and charge your phones.
We have another question. Thank you. Another question. Can the universal robots be mounted on a mobile platform and moved from location to location?
So there are multiple ways to do that. One, there are like mobile platforms available for it. Did you mean this? Was the question meant to be like a moving mobile platform or a non-moving?
Yes. The question was, couldn't the robot be mounted on a mobile platform, be locked in place for an application and then detached and rolled somewhere else for another use?
There are cards available to the universal robots which can log into like machines, and you can 10 different machines and pull the card and load it into a different machine. You can just open a different program and run through it.
I think that question originated because it was planning on being redeployed from one application to another after the initial application was completed.
Okay.
So, thank you. Other questions? Question about the payload. How do you choose which robot to deploy for an application? Is it only the payload that you have to look at?
So the major part is the two things. One is the payload. One is the payload, and second is the reach. So depending on what kind of a reach and the payload you need to choose the type of robot. So if there is a smaller payload like 1 kilogram, but you need like a larger reach, you have to like use the UR10 in that case. So if you have like a shorter reach and lesser payload, you can use like UR10. So it depends on what kind of a payload and what kind of reach you need. That's what it is. Is it the other questions?
The other question was, when do you use vision? How do you decide when vision is necessary?
That's a good question. So the vision system depends on the places where the objects to be picked are if it's in a random positions. Meaning like if you saw the palette program, the robot knew where the coordinates were, and if it was in a random point each time, that's when the vision system is an added advantage to it. So it before picking up, it scans and knows the coordinates of the object. So if the robot scans right now, picks the part and goes over to processing something, and when it comes back, if I throw like another 3 objects here, so this is completely random. So the robot would again take the camera or the vision system would take a picture, get the coordinates of the new items available or whatever has been changed, and processes it. So depending on the randomness, if the application has parts in a very specific places, that means you can directly define the waypoints and you can use the force torque sensor and you can go with it. And also, you can, if there are randomness in the object, you can use the force torque sensor but again that would add more delay or increases the cycle time. So if you have like a cycle time constraint and you need to do it faster, vision systems are the go-to solution.
Thank you. We have one last question. I think I'll answer this one. The question was, what are the key factors for successful installation of the collaborative robots? I would like to answer that one. We've installed a lot of robots in the area. Access New Jersey was one of the original distributors for the UR product. So over the years, we've installed a lot of robots. And if I sum up what are the most important factors leading to success, I would say the first point would be to choose the correct application. Many people get excited about the idea of the collaborative robot, and sometimes they go for the most complicated applications to begin with. And we always encourage them to try the first application should be a fairly simple application. And usually that relates to a fixed pick and a fixed place. And with that sort of an application, it's a really quick deployment. Once you get used to the system, you can always add complexity. We had a case in the area where the customer started by fixing the pick and fixing the place. And then once they mastered that, then they became dynamic on the pick and then dynamic on the place. And ultimately, it was a multi-phase deployment, but it went very successfully, rather than making it very complicated in the beginning and wait a long time to see results. The other success factor that we've noticed is that if there's an in-house product champion, in other words, at the customer that's deploying the cobot, if there's someone at their facility that takes ownership of the project, Access New Jersey has certified training classes that we encourage our customers to attend. And if the folks that are deploying the robot are comfortable, sometimes customers come before they even receive the robot just so they can prepare themselves and really make it smooth when they receive the robot. But I think a on-site product champion and someone who's knowledgeable about what the product can and can't do, those are probably the two most important factors for success from my point of view.
I agree with that.
I have no more questions. Are there any other questions? Let's see. Okay. No more questions.
Okay.
So in closing, I'd like to say that we hope this was an interesting introduction to how the cobot works. We'd very much like to set up a personalized call with you to discuss your applications in detail. We can review what you're thinking about and give recommendations. And we look forward to hearing from you. And that concludes our presentation. Karthik, do you have anything to sum up?
I think, yeah, like you pretty much summed up those important aspects of successful applications. So, yeah.
Oh, I have another question. Where is the program stored? That's a really great question. Where is the program stored? Are the changes saved automatically?
Okay, that's a good question.
That's a great question. Go ahead, Karthik.
Yes.
I'll mute myself so I don't reverb.
Sure. So the programs are stored inside the robot controller. So it has its own SD card, and the data and the program, everything is stored in that. Just like any application like your spreadsheets or PowerPoint, I would say like if you're able to see here, like the program doesn't automatically save. It creates an asterisk after the name and the installation file. So if it's not saved, you need to like click save, and you have the option of saving the program, save program as, or the save installation file as. So if you click save all, it would save both. Or when you're like shutting down, it would ask you like there has been changes made into your program or installation file. Do you want to save or do you want to discard those changes? So based on how or what things you change, you can say whether to discard or save it. And just to conclude, the programs are all saved on your computer, and you have your own, the robot has its own USB stick, where you can copy those programs and extract to your computer, and you can look at it as a text file and just see like how this whole program is. The whole program tree is converted into a text file. And you also have a .urp file, which is the Universal Robot Program specific file, which is read onto the teach pendant. And in the background, it also generates a .script file, which is basically a Python code wrapped into it. So that's the file which gets executed on the robot. So the .urp file gets converted to a .script file and executes on the robot. So you can access all these files through the teach pendant, the USB stick, or you can shut down the robot, take the SD card out, copy the files, or you can also FTP straight into the robot, and you can access all the files into it and copy to your desktop. Hope that answers your question.
Thank you, Karthik. Yes, that's great. Thank you. I would add that a lot of times I have a customer who has they told me that when they purchased their first robot, they have 11 now, but when they purchased their first robot, they paid for it within a few weeks because they had done a big run of metal bending application for a big box store, and within a few days they'd already paid for the robot. And I asked them, what was the smallest amount of pieces that you ever did a program for? And they said they once did a run for about 1,500 pieces that they made a program for. So that in this particular case, they have lots of programs stored in their robot on their teach pendant, and then as they get a job, they can go back and pull that program up again. Sometimes they may take that program and copy it and make small modifications to create a new program, but ultimately they have a library of programs stored, and when they get a job, they can pull it up. So over time, you build yourself, a nice library of programs in the system.
Okay. So to answer the next question, is the teach pendant the only way to program? The simple answer is no. The teach pendant gives you the nodes for you to create a program which has simple, the templates or the nodes-based application. But there are multiple ways. One, which I told you, we'll be posting a blog post. Keep a lookout on the website. So what we can do is we can connect a computer and write a script and send that file over to the robot to program it. You can create your own motion waypoints and actuate the gripper. You can toggle I/O ports, and you can do various things, which can be written in Python. And the another way is to control through ROS. The Universal Robot has an open architecture. So there is the official Universal Robot's ROS driver, where you can program it through ROS and have your own Python script, and the model would be shown up into VREP software, and then you can program and you can have your own obstacle avoidance systems into it, so that the robot avoids the collision between the objects while the path or the motion planning is being executed. Hope that answers their question. Is there any other question?
There's a question about what if the reach is further away than the longest reach of a robot? Is there any way to compensate for that?
Okay, so the robot has the capability to be placed on a 7th axis. So if the robot is not able to reach the largest, which is the UR10, if it's not able to reach, that can be placed onto a 7th axis, and you can slide in X, Y, or if you want it to be mounted on the overhanging design, you can have it that way too. So based on the if it's not reachable, yes, that's the best solution for a 7th axis.
That concludes all the questions I'm aware of. Are there any other questions?
Okay, yeah. Okay, there is another question. What is the price for smallest unit, like the one we demoed?
Well, we could discuss that, because there's so many considerations, because we'd want to look at, when we're looking at pricing a robot, you want to look at the price of the robot arm. Then we want to talk about the type of grippers and mounting. So I think it's better to answer